Now let's see Coulomb's law in vector form, or force between the charges in vector form. This is the magnitude, and now we'll deal with the vector form of Coulomb's law. Suppose position of Q1 is given by A and that of Q2 is given by B. Then force on Q2 by Q1. If we write its vector form, then every vector has some magnitude as well as direction, and therefore we can write F like this. Magnitude, we already know that magnitude is K times Q1 Q2 upon R square. Now assuming both charges are positive, we can see that Q1 will repel Q2 in this direction. Now this direction is given by A to B. Q2 experiences a force away from Q1 and is given by A to B. But we don't write like A to B. What we write is K Q1 Q2 upon R square. This A to B or direction is given with the help of unit vectors. Or do you write unit vector? You will say AB cap. So this is the magnitude and this is the direction. A to B. A to B is nothing but AB cap. Once you write AB cap, now what is AB cap? We'll see it here. Any unit vector can be obtained by dividing vector with its own magnitude. If you divide vector AB with its own magnitude, you get unit vector. Suppose the vector has magnitude of 5. What you are doing is you are dividing 5 by 5. 5 upon 5 becomes 1 and magnitude of a unit vector is 1 only. And therefore AB cap can be given by AB vector upon AB. Now this AB in short can be written as R vector. The separation R between A and B is given by R vector. And magnitude can be directly written as R. If I don't use the arrow, it gives me the magnitude. So AB cap is basically R vector divided by R. Now this AB cap can also be written as R cap, which means direction A to B is nothing but R cap. What R cap is? R vector divided by its own magnitude. That means this force now is K times Q1 Q2 upon R square. Now AB cap is what? R cap. We'll write R cap here. And then this thing becomes K times Q1 Q2 upon R square. Now look here. R cap is nothing but R vector divided by its magnitude R. And therefore this R cap is R vector divided by R. Together with R square, you get K Q1 Q2 R vector divided by R cube. So this is the vector form of Coulomb's law. But remember, force is not inversely proportional to the cube of r. This r itself has a magnitude of r. That r and r cube becomes 1 upon r square. The force is still inversely proportional to r square. When you write like this, it says magnitude, this much part, this much portion gives you the magnitude, and this r cap gives you the direction. Whereas in this part, k q1 q2 upon r cube is not the only magnitude, because magnitude also lies with, partly magnitude also lies with this r vector. And therefore, force, when you write on q2 by q1 in vector form, if you are using unit vector, should be given by k q1 q2 upon r square times r cap. And in complete vector form, it is given by k q1 q2 upon r cube multiplied by r vector.